All right. Next up is our own Ten Thiessen, who's going to talk a little bit about the way he's our release manager, by the way. So he's going to talk a little bit about the way he rolls out the pre-releases onto our Condor pool and maybe give some suggestions how you might roll out releases onto your own pools.
Yeah, so I'm going to talk today about the way that we install Condor on our CHTC pool. And we try to do this on a running cluster and try minimal user impact. So how do you upgrade a large pool? Well, you can let the uh, package manager overnight just update all the Condor packages and everything all starts all at the same time. Jobs will be evicted and your users will kind of notice that. So that's not what we do. I've heard of some sites that will drain all the nodes. And once everything's drained, they'll just have a downtime and then they'll update everything and make sure it's all the same version. And in that case, your users are unhappy, the pool's not unavailable. So we have to do an update every month because we have a monthly release cycle. And sometimes our release candidates have defects that we have to fix during the release cycle. So we end up actually doing multiple updates in a month. So, what is HTCondor Pool? It's a distributed system and it recovers from network hiccups. Since 23.10.2, the central manager can go down at one IP address and come up at a different one. There's an adjustment we had to make in the days of Kubernetes where things are a little bit more ephemeral, but machines can come and go. The other thing I want to talk about is the version compatibility. We try to make sure that every version of Condor will communicate with other versions. Michael alluded to that a little bit, but we guarantee that adjacent major versions will communicate. So any 23 will communicate with any 24. Although, as you mentioned, you may be missing some features. So two pools that I work closely with is our CHTC pool and our BAT lab. So the CHTC pool runs primarily the feature version, our latest 24X. So the central manager is running 24X. And we have a test AP that we use for early testing. And then we have a few test EPs. And we try to cover each operating system, whether or not they have a GPU, CPU architecture. And so on our first day of upgrade, I'm working with those tests to make sure that everything is working fine. We also sprinkle into this pool a few LTS nodes. So we have an LTS AP, and this is running our nightly tests for our OSG software stack. So that's something that gets used every night. And so if there's a problem with interoperation between 23 and 24, we'll find about it right away. And then we have a few LTS EPs, and there we're trying to get like one of each to make sure. The BAT lab pool is used by our development team, HTCSS, and this is where we build all our software. So if there's a problem with Condor, we're going to shoot ourselves in the foot first. So this one is running LTS Central Manager. And then we have an AP that we run the feature release. Our build process is heavily in Dagman using Docker jobs. And so we would detect a problem with that right away. And so we have one LTS EP running Docker jobs, and then the rest are feature EPs. And we have a few Windows and Mac EPs mixed in. So here you can look at a snapshot of our CHTC pool last week. You can see it's a mix of 23 and 24, but primarily 24.8. And you can also look at the version strings. We're all running release candidates. In fact, this pool never sees a final release because by the time we release, we're on to the next release candidate. The BAT lab, this is the mixed pool that I talked about where we build our software. You can see that we're pretty much current, but you can see that we have a few old nodes. Those are Mac and Windows nodes that don't get updated very often. But all the Linux nodes get updated with each release cycle. And then the OS pool. The OS pool you can see is running primarily 24/8. They run glide-ins, and so last week we had 6,000 pilots running the 24/8.1 release candidate, and we're still retiring 24/7. So pilots will run for a while, and then they retire, and then a new one's instantiated. So how do I upgrade our CHTC pool? Well, on day one, I get the release candidate posted. Usually we don't have any problems with LTS updates, so I update all the LTS nodes, and then I update the test nodes. And I run test jobs. And right away on the first day, we'll know if there's a problem. Whoops. We'll know if there's a problem in the bat lab because we're running jobs there. The nice thing about the bat lab pool is it's a small pool, so we update everything all at once. Our longest jobs tend to be about 90 minutes. But after day one, I have a good idea if this is a good release that we can start rolling out onto the CHTC pool. On day two, I update the central manager, most of the APs, and I kick off an upgrade on 25% of the execution points. And I'll talk about that. But those execution points take a little while to update. On day three, if that is all going well, I update our very busy APs. So these are APs that have several thousand jobs running and watch the restart of that and make sure that all goes smoothly. And then I keep on every day, I kick off another 25% of execution points. So we manage this all with Puppet. There's a few upgrade, downgrade mechanics that we have to work. And I'm just going to talk about what we do in Puppet, but whatever management system you use, you should probably do these things. We need to be able to downgrade in case we have a bad release. And so we have to group these are our 4 RPMs that we're installing. And if you just say yum downgrade Condor, yum is not smart enough to say, oh, I'm downgrading Condor. Oh, but Python Condor is a newer version and it needs the new version of Condor. No, I can't downgrade. So we have to put some special Puppet code in so that when we do a downgrade, we downgrade them all together at once. And the way that we manage this in Puppet, we actually specify the exact version right down to the build number that we want to install. And then in the repositories, Puppet makes sure that we can only see the packages that match that version number. So we have these Puppet files, and each type of node, like the EPs in these waves, or test nodes, can have a Puppet specification for the version. We do a few host by host, like here are two busy APs or our high memory nodes. So sometimes it's a node, sometimes it's a class of nodes. It all depends on how you want to handle the update. So let's talk about a central manager upgrade. So the central manager includes the collector and the negotiator. And the collector is mainly an in-memory database of what your cluster looks like. And there's really no reason to save any state there because you take the collector down, you bring the collector back up, and all daemons have an update interval. Most daemons' update interval is 5 minutes. So you wait 5 minutes, and then your entire in-memory database has been fully repopulated. The negotiator has a save state. This save state goes into a count and log file. So we do a graceful restart, and that's the default. So when a new binary shows up, you do a graceful restart. It takes itself down orderly, make sure that the count and log file is in good state. And then one other thing I want to mention is we do adjust our claim work life in CHTC. Because every once in a while we have a bad central manager upgrade and we have to take time to diagnose and so forth. And so this is mainly for APs, but the claim work life, which is normally 20 minutes, we set that to 12 hours. And that means that when an AP has been given a claim and it has more jobs that fit into that claim, it can continue sending those jobs to EPs. And that's actually worked out to our advantage once when we had our HTC pool is actually spread over 3 data centers, and we had the network partition. So APs and EPs that were in the same building kept on running jobs, even though there wasn't any central manager there for a time. Access points. Now, this is where your users are most likely to see your upgrade. And with the access points, you want them to come down quickly and come right back up quickly. And so we switch over to the fast restart mode. So in fast restarts, the daemons get killed right away. The job queue log is saved transactionally, so there's no problem there. The reason you don't want to do graceful is like we have credmons and credds always come down very quickly. And then somebody tries to submit a job that needs credentials and it says, I can't find your credentials. The other thing that we change is the master new binary delay. So once it detects a new binary and it takes everything down, 5 seconds later, it brings it up. And in CCC, this upgrade is initiated by Puppet on even hours. And I'll talk a little bit more about claims and leases. So a claim is handed out by the negotiator, and the SCED will claim a slot on an EP. And the claim work life right now is 12 hours in our pool. The job leases that claim for 40 minutes, and it renews its lease every 5 minutes. And so if the SCED goes down and comes back up, then the SCED has up to 40 minutes to reconnect back to a running job. So execution point updates. Now, people are unhappy if you take your execution point down fast because you lose all the job progress. And so we have set our shutdown graceful timer to 18 hours. And what that means is that when it detects a new master binary, it starts retiring jobs. Well, it puts them in retiring state, which means you have 18 hours to finish. And usually we have about half of our EPs in that time frame, finish all the jobs that are running on that EP, and restart and come back into the pool. But after 18 hours, if the job hasn't completed, they get evicted and end up running someplace else. We have some high memory EPs where these are hard to match jobs, and we want those jobs to be able to complete no matter what. So I would like to have a restart mode that's strained, but we don't have one. And so so luckily there's only a handful. We set the master restart to never. And then after the Puppet has upgraded the software, I cancel any drain that may happen to be running on that EP. And then I do a Condor restart with drain. And what that does is it will drain the machine until all the jobs either finish or are kicked off because they've gotten to the max job retirement time. And I put a reason there so that anybody that looks at this drain, especially the defrag daemon, can see, oh, that's a manual drain that somebody's done. So do users really not notice? Well, it turns out that regular users do not notice us going through those updates. However, our drain policy and restart, we have a policy for regular EPs that it will only accept jobs in the first 20 minutes that request at least 4 cores or half the disk on the EP. So we have some disk memory and core memory jobs that are harder to match. Same thing with the high memory nodes. 20 minutes after restart, it has to be a request memory of 100 gigabytes or more. And once the 20 minutes is up, then anything can match there. So users with these hard to match jobs, when we're doing a upgrade, kind of get a little bit of preferential treatment. So we may have to adjust the expectations a little bit when we're not doing an upgrade. And also frequent upgrades have masked broken defrag configurations in our pool. So here's a quick summary of the configuration knobs that I put the claim work life and the binary restarts and graceful shutdowns. Those are for your reference if you want to cut and paste into your configuration. Talk a little bit about DevOps. So the dev team is me, especially the risk manager, is involved in these upgrades. And this serves to give a lot of advantages to the users, to the infrastructure team, and to the dev team. We used to just throw the software over the wall to the infrastructure team. They have to figure out how they're going to fit this upgrade into their priorities. They don't know what's changed. And I'm using we and they, but we're really all the same team. So, you know, the dev team knows where to look for possible issues. We get this out on the cluster sooner. The users get the updates quicker. In the past, the infrastructure team, they're very sharp. They will find an issue and they'll work around it. But if I'm doing it, I see the issue and I say, oh, this needs to be improved. We don't want to have a workaround, a Band-Aid. We need to fix it so it's better in the future. The other thing is the infrastructure team loves it that I touch every node in the pool every month. And so, I mean, they're monitoring to make sure that things are working properly, but there are some things that just don't get detected. So if a node doesn't upgrade to Condor, I'm looking at that node. What is the problem? I can fix the very simple problems. Fix stuck puppet runs, DNF cache gets corrupted, Ceph mounts get hung. But if there's anything else that is takes more effort, then that gets passed off to the infrastructure team. Wanted to make a little slide here about, we have actually 4 different repositories for each Condor version. We have a snapshot version, which has the latest build that passes all of our integration tests, and that feeds into the OSG development repositories. We have an alpha repository, and that one is what's used to do testing on CHTC. We have a beta release candidate, and this is more of a public that other people, if they want to test early features, they can do that. That also feeds into the OSG testing repository. And then we have release repositories, and that has all the releases. For example, the snapshot repository just has the last release. The alpha and beta have the current release candidates and last month's release candidates. But we keep the release repositories, you know, as long as practical, indefinitely. Although once the version goes out of support, we would only have the very last release in that repository. So we have releases going back to 8.8 on our website. Although we don't support them, they use it at your own risk. If you find a defect, if it's easy to fix, we can tell you how to work around it. If not, we'll tell you to upgrade. This is the pool version script. I don't expect you to read it. That's the cut and paste if you want to use it. The acknowledgement to the NSF and the grant, but I also want to acknowledge the dev team that helped me put together this talk and actually made it much improved. And also our partnership with LIGO collaboration. Stuart Anderson in particular, he actually runs a small test pool out of the snapshot release, out of the alpha, out of the beta. And sometimes Stuart lets us know about issues that we hadn't noticed in CHTC so we can correct them before release. And so I'm going to just quickly go to a terminal window here. And let's see. We can look at how we're actually upgrading the pool. Let's see, can I make that bigger? In terminal, is there a way to make this bigger, TJ?
I think plus
What's that?
Control plus.
Control plus?
Control plus.
It's not doing it. It usually does it.
No, Control.
Control?
Yeah.
Control plus.
Nope.
Control shift.
Is this,
Well, I tried
is this
that.
a Windows
Okay,
box?
this is the Windows box, yeah. Yeah, so the thing that I wanted to show you there is we're actually going through an upgrade right now. We're just completed wave 2 and we're on to wave 3. Oh yeah, there you go. No, font font size. Yeah. Just make it bigger. Yeah, that's better. Yeah. That's somewhat readable. So you can see here 24.9 is the one that's being installed and 24.8 is the one that's going out. So we have roughly 250 nodes and right now we've gotten a little bit over half has upgraded. So at this point, I'll open it up to any questions. Right there.
Over here.
Hi, I'm Tom from BNL. If you saw my talk yesterday, you'd know that this is very near and dear to my heart. This Condor upgrade.
Yeah, I'm sorry I missed it. I had to be upstairs for other duties, so
I figured as much. So this is why I wanted to bring it up.
Okay.
So it's maybe not a question, but more of just a comment in general. I've tried loads of different upgrade procedures, upgrading in batches, scripts to basically monitor the Condor Who and upgrade an EP as soon as it can be upgraded. But no matter how I cut it, I either end up wasting a ton of CPU cycles, waiting for the node to drain, or if I kill jobs early and evict them early, you're wasting already used CPU. So if we consider the mean time to drain multiplied by the number of CPUs I have in my site, every time I want to upgrade, we're talking about CPU hours in the 7 figures being essentially wasted. So upgrading, we would love to be able to follow LTS every month, but it's just completely untenable for our site. We can't sell that to our users to waste millions of CPU hours every single month to upgrade. So that's something that I would like to maybe see a less painful way to upgrade EPs incorporated into Condor in the future. So not a question, but more about.
Yeah, it's more of a statement. Yeah, I mean, we had to balance with the 18-hour retirement time between the average job lifetime and having on empty slots. And so we're doing the best we can with what we have.
So I think that the question here is, let's assume for the sake of the discussion that I'm smart in picking execution points to upgrade. Can we upgrade one execution point at a time until we got all execution point upgraded? Now, somebody else will be responsible of picking the execution points in a smart way. I don't expect that to be in your space, but can you tell somebody who is upgrading, you can upgrade one execution point at a time and everything will be fine? For this release, I'm not saying all releases, if once a year I have to shut the whole thing down to upgrade, it's fine. But if I want to keep up with the releases, can I do it one execution point at a time? That, to me, is the first step in addressing the waste factor. So is that a pipe dream, or is that just a matter of doing things right?
Yeah, there's a tension here about our release cycle where, we have to get a certain number of nodes upgraded. So the 25% was chosen so I could get it done in 4 days. So I would get.
I'm surprised. What prevents me from? I mean, I can run a mixed cluster, right? I mean, in most cases, I'm talking just about the execution point.
Okay.
Not the collector, not the access point. The access point seems to be that we can do it in a way that doesn't cost him cycles. But in the name of efficiency or God knows what, somebody else will pick them. But can I say upgrade this and everything will be fine? It will drain, it will upgrade, and it will come back and happiness. And then I can say the other one. How I pick them, my problem. But can I do it?
Not automatically. Yeah.
Yeah. Can you give me a command that says upgrade this one and let me know when it was upgraded? I will do the automation. I'm not expecting you to do the
Okay.
automation. I'm just expecting you to give me a primitive
Yeah.
that says, and you know that I can do it given all the new bells and whistles and everything that's involved in it and all the other stuff.
So I can take this one. If you set up the master configuration ahead of time, the configuration of the master ahead of time. So you have to prepare ahead of time when you first install the Condor master. Then you can send the master a command that says drain and then restart, but run this script the next time you start. And that script could pull the new version. So yes, this is possible.
Can you give me a tool that I can do it?
We could,
Yeah,
yes.
we could. Yeah.
So I think that would be, and you know that it will work, that you tried it in your testing, and you know that for this release, I understand that there are releases that the whole world is a new world and we have to, so think about creating such a tool and then we can build something on top of it.
Okay.
All right. Do we
Igor.
have other questions? Yes.
Yeah.
You're taking in your own time, so.
Okay, so actually I have a question for you since you had a question. So the reason why you lose so much time every time you upgrade, I guess it's because you have you partition each machine a lot. So you have a lot of slots that when you drain them, take forever to drain down. Is that correct?
Just exit. Oh, I see.
Yeah.
It's
Just
not,
got-
just kill it.
Yeah.
Yeah, that's just kill it.
So when we start the upgrade process, we're draining the nodes, and our job mixes usually follows a pretty standard distribution. So you'll see in general, when you start draining the node, it usually is like a logistic curve. You know, some jobs finish right away, some jobs are somewhere in between, and then there's almost always a long tail of jobs.
Right, but you have a lot of them on the same node. That's the question. If you have different jobs on different nodes, you can upgrade different nodes at different time, like Miron says. But do you have a lot of jobs of different sizes on the same node, and that's what it's the root cause of all the waste?
Yeah, so we really don't determine which jobs land where. The pools are pretty uniform, and the job mixes are usually pretty evenly distributed.
But
So
on a single node, I'm asking.
on a single node, it's like all things, it depends. Sometimes your EP will drain the whole thing in an hour because just so happens the jobs that were living on it at the time were fast jobs. But
The question is, how many jobs do you have on that machine? Typically.
typically, it also depends. In the worst case, all of the jobs on the EP are single core jobs. So the number of jobs would be the number of cores usually. It could be between 96 or 128, depending on which generation of machine we have.
I had one more question for you as well. Have you investigated the ability to run jobs while you're training? Something I think added during the
Yeah,
24
yeah,
series.
you apparently, and we need to get a mic on you because
Yeah,
you're next.
sorry.
Sorry, what was the question?
So you were saying the issue is that I've got, this one long running job and it's keeping 94 cores idle or how many ever.
Yeah.
And the question was, have you looked into using some of these shorter jobs to run while that job is draining? Because that is something we can do.
I don't know if that's possible. I mean, I guess that's a better question for the Condor devs. I would love to
Sorry.
be able
Being
to.
a Condor dev, I'm telling you it is possible.
Oh, yes. Oh,
I should have been
okay.
clear about that.
That would be really interesting, definitely.
Great. We'll talk after.
I think that if it's also a user experience, when he drains everything, suddenly there is a huge drop and everyone notices it. If he sneaks in one machine at a time over a week or several weeks, then not noticed, and some of it is more the psychology of the users rather than the number of core hours that are being wasted or not wasted. So I think that, first of all, being able to do it systematically and in a dependable way, one node at a time, let's start there. And then we can think about packaging and running a different mix and squeezing the lemon. But at the moment, we don't have a way to do it one node at a time.
Yeah, so I've done in the past a kind of a custom script outside of Condor where I would essentially kick off a batch of upgrades and it would say start on 10 nodes. It would drain the nodes. It would watch the Condor who as soon as you had 0 starters on that node, it would upgrade it, do a couple sanity checks, restart Condor, and then kick off the next upgrade. So that was as close to the best case scenario that we had, but we were still ending up with, if you take that across the entire pool, you still have a mean time to drain multiplied by the number of CPUs. We can't get past the fact that even if your granularity is single EP, that was still wasteful when you add that up.
Going to be free.
Right. Exactly.
So the question is it a small interruption in the productivity? And then we have to see whether we can make it smarter. But rather than you running your script, I would like to address it in a more systematic way, and also to make sure that we know that this will work.
Yeah, that would be awesome. Thank you.
All right.